Hello, welcome to this tutorial on user interface design for virtual reality. I've created a simple scene in ShapeXR to sort of explain some of the concept by Alex Chu, a researcher, who's basically looked at range of view and head motion. Chu defines two concentric rectangular guides, one that's called comfortable range of motion and the one that's called maximum range of motion. The green lines show the comfortable range of motion. This is 20° up, 30° to the right, minus 12° to the bottom, and a 30° to the left. So 60° left and right. This is the maximum. The gray lines show the maximum. That's turning your head without starting to have a neck pain. Down and up. And you see right there, it's pretty much the maximum. So that's 60° up, minus 40 down. And 55° on both sides, so a total of 110 range of motion, side to side. If you want to go more than that, you need to turn your body, and this is completely behind me now, but I had to move my torso. I'm sitting down, so it's not easy. So all the way to the back. So if I move and I push really hard, I can see past the maximum, but this is not very comfortable. In VR, the eyes of the user is a camera, and there's distance. It's a 3D space. If we look to the left, there seem to be 3 panels, different colors, but all the same size. But are they really? So the first panel is 50 centimeter by 30 centimeter. And it's a meter away from the viewer. The second is 2 meters away, and it's basically double that size. And the third panel is 4 meters away, and it's basically 4 times the size as the first one. Although the user doesn't see difference in size because they're far away in space, you can see it from sideways that there's quite a difference. Researchers at Google came up with a new unit. It's called a DIM. It's a distance independent millimeter. So it means that if you make a panel that's 40 centimeter or 400 millimeter wide by 480 tall, it will show at 1 meter as being the right size. But if you want to make it readable at 2 meters, you're going to have to double the size. And at 3 meters, you're going to have to triple the size. And at 4 meters, you're going to have to quadruple the size. Each square on the checkerboard is a meter by a meter. So if we look at a user and the interface is a meter away from her, in this case, let's get right into her head at 100%. So I'm seeing a screen, an interface that is 500 millimeter wide by 350 tall, with some guidelines showing the space between each interface element. I guess it's a standard in MetaQuest. But this is readable from a distance of about a meter. And if we look from the side, we see that the panel is at a meter and at a comfortable height so that the user does not have to crane their neck. Beside these panels, which are already an hybrid from graphic user interface on computers, there's also the concept of palettes, for example, which is typically attached to the user through a bracelet or on the controller itself. And it gives you tools right there that you carry around and use at your will. This pile of blocks is 10 meters high. Let's talk about distance and perception of 3D. If we look over there, I did 100 meters around, about 140 to the corner. This whole scene is 200 meters by 200 meters, which is quite big. And as you can see, the detail in the models at the edge of the scene are, pretty limited. This is due to the resolution of our end-mounted display. Let's recap. LX2 comfort zone is about 20 degrees up and 12 degrees down, for a total of about 32 degrees. And 60 degrees right to left, without moving the head. Thank you for watching this tutorial, and I hope you learned something new. Thank you.